So if I'm off the screen, I can't see behind myself and then keep turning around. If I'm off the screen, just tell me. So I'm not writing off the screen and realize like 5 minutes later. So to set up a domain and range, the domain is the input values. Input. Range is the output. A professional basketball player earns $150,000 for each game played, and there are 82 games in a season. One value up there determines the other value. Which value do you have to have first to get the other value? There's 2 variables. We've got money and games played. Games what?
I heard the question, but I didn't.
What has to happen first to determine the other thing? What happens first? You have to play a game before you get paid. Yeah? So, is this professional basketball player for sure playing every single game? So there's a range of games that this basketball player could play. So we know the domain is going to be games played. What is the lowest amount of games that the basketball player could play? 0. You might be hurt. What is the highest amount of games the basketball player could play? 82. So to describe any number in between 0 and 82, but including 0 and 82, we're going to say 0 less than equal to x less than equal to 82. And I chose x because usually x is the domain. So that would be how many games this person can play. So how much money could this person earn? What is the lowest amount? I'm writing range is money earned. Could earn 0. What is the maximum that the player could earn?
Or
You mean 150,000? Okay, yes. I'm like trying to figure out where we got that number. 150,000 multiplied by how many? 82. So go ahead and shortcut that answer. I'm going to do it by hand. $12,300,000. So now what I want you to do is number 2. I want you to think about if you eat up to 5 meals a day with an average of 844 milligrams of potassium, what would the domain be? What would the range be? Write it down. You're using pencil, hopefully, or erasable pen. That way you can change it if you make a mistake. And number 3, the average amount of money spent on food per person at an amusement park can accommodate 2,500 people is $5 per person. So with number 2, you eat up to 5 meals a day with 844 milligrams of potassium at each meal. What has to come first to determine the other thing? You have to eat before you know how much potassium you eat. So, domain would be number of meals. And range would be milligrams of potassium. What's potassium in? You know? Bananas? Potatoes? That's all I know. Bananas, potatoes. Probably more. Okay, so what would the domain be? It's the number of meals up to 5 meals a day. What's our domain? Morgan, do you know? No, Morgan. Yes, Morgan. I know, that was Listerman.
So is it 0 is less than or equal to x less than or equal to 5?
Yes, it is. Oops, wrong one. And the range would be the milligrams of potassium. If we eat 0 meals, how much potassium do we have? 0. So 0 less than equal to y, less than equal to what's the maximum that we're going to have? You tell me again? 4,220? And how'd you get that other one? Okay. 844 times 5. And then number 3, the domain is going to be the thing that happens first. People go in the park before they spend money on food. So the domain is number of people in park, which is going to be between 0 and 2,500. Range will be money spent on food. Which is going to be between 0 and, you have that number for me? You guys agree? I didn't do it, so hopefully that's right. And you did that by multiplying 525 by 2,500, correct? So you can read and decipher the meaning of stuff. That's all that's new today is we're going to do the things that we've already done in here. It's just going to be in like a real life situation rather than, here's an equation, graph it. It's going to be meaning things today. Down here is just a review of the 3 formulas we used on the very first section, which you already have the notes from. You still have the notes. Remember, if we're doing slope-intercept form, we have y equals mx plus b. M is the slope, b is the y-intercept, right? And then if we want to find an equation, we would use point slope form, where you plug in the ordered pair and the slope. You were supposed to do this on the first quiz, and overall, you all did pretty good on that quiz. And then if you have 2 points, you would find the slope formula, which they did not write on here, so let's write down the slope formula just in case we forgot. It is y2 minus y1 over x2 minus x1. And then you would use point slope form to find the equation. So that's all we're doing today. Just doing it with some words.
So on the first page, for every single one of them, they start out 0 is less than or equal to x. So always start like that, and then the last number is the only thing that you're figuring out.
For the warm-up, yes. It's not like everything that we'll ever do with that. Because we couldn't have negative people go into the park, right? So 0 would be the least amount. All right, so we have a graph, and this graph is asteroid 2012 DA14 data. Here on the x-axis, this is the domain or the input. Is time in seconds. So as time is passing, this asteroid is moving. Distance miles. So this would be the output or the range. So as time is progressing, like time does, this asteroid is moving. The graph shows the distance asteroid 2012 DA14 travels in x seconds. Write an equation of the line and interpret the slope. So I'm going to start by interpreting the slope, which we're going to have to find the slope, but we're going to start with interpreting the slope. So let's find the slope first. We're going to use our slope formula, which says y2 minus y1 over x2 minus x1, and if you don't have it memorized, write it every time. Now to do this, I need 2 ordered pairs. One of the ordered pairs, they've listed 524. Is there another ordered pair that we can figure out easily? 0, 0, does it go through 0, 0? Looks like it. So let's use that one as our other ordered pair. So we will do 24 minus 0 over 5 minus 0. 24 fifths. Now I have to interpret that. So the y's are the distance and the x's is the time. So I'm going to interpret this as like the asteroid is traveling 24 miles per 5 seconds. But I want you to simplify that thought. I want this to be something where we write the miles per second. Actually, I don't need that blank. I want to write the miles per second. So we could say 24 miles per 5 seconds. We could say that, but I wanted to reduce, so I can say how many miles per second. Because that is usually a rate that we would use. We wouldn't use per 5 miles or per 5 seconds. Like when you drive a car, you're not driving 60 miles per 5 minutes, or you always say per hour, right? So we want to reduce it down, so it's like per something. So to reduce that, what operation is 24 over 5? It's division. So you type in your calculator 24 divided by 5. 4.8 miles per second. So that is interpreting the slope. We're using the y values and the x values given on the sides of the problem. Interpreting the slope. Now we have to find the equation of the line. So we need we need 1 point and the slope. Which point would you like to use? You want to use that one? Okay. So we're going to do point slope form. Just a reminder, point slope form is y minus y1 equals m times x minus x1. We plug in for our slope, which I'm going to use 24 fifths. And we plug in x1, y1. Now we're going to distribute. So I get y minus 24 equals 24 fifths x. And And when I go to multiply a whole number by a fraction, 24 over 5 multiplied by 5 over 1, we multiply straight across. And what do we get? You get 24.
Yeah.
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 You get, did you say 120 over
Yeah, so
5?
120 over 5 gives
And then it reduces to 24. Okay? And then from there we're going to add 24 to both sides, so the y is by itself. But when I add 24 to the other side, yeah, it just cancels out. So we get y equals 24 fifths x. So that is our equation. Okay, so that's equation 1. Yes, right.
Why is it minus 24?
It's plus 24.
On top of
Wait, I don't, where was he?
above where you said add 24.
Oh, here? Because I multiplied these together, and we got, I didn't show the in-between step. We got 120 over 5, and when you divide those, they equal 24. I didn't know which 24 you were talking about. Gotcha. All right, the asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that distance? So the asteroid was 17,200 miles from Earth. We need to know how long it takes. You already have the answer. Okay, one moment. We need to know how long it takes to travel that far. So in my equation that I have up here, which of these variables represents distance? Which of these variables represents distance? Y. Which one's on the Y? Oh. Distance, right? So in the Y part, that's where I'm going to put in 17,200. Am I on the screen? Barely. And then on the other side of the equation, I keep it as 24 fifths x. So we're going to solve for x to find out how long, how many seconds it would have taken for the asteroid to come hit Earth.
You were 25.
Yeah, I don't know why. Yeah, I don't know why I did that. Thank you. So now, how do I cancel out a fraction 24 fifths that is being multiplied by x? So I get x by itself. How do I cancel that? You multiply by its reciprocal. So we multiply by 5 over 24 to both sides. So on this side, the 24s and the 5s should cancel out. You should get 120 over 120, that's x. But on this side, we have to put 17,200 over 1. We need to multiply straight across. So 5 times 17,200. 86,000. Divide by 24. We get 3,583.3, and that is what units? This is seconds. Yeah, so we don't normally talk like, oh yeah, 3,000 seconds, that's how long it took. We don't talk like that.
All I did was divide 17,200 by 48.
Oh, because, hold on. Oh, did that work?
Yeah.
Okay. So at this point, if I want to know how many minutes or how many hours, right now it's seconds. So if I took that and I said, all right, how about that answer? And I divide that by 60, it's going to change it in a minute. Yeah, 59 minutes. And it's approximately 72 seconds. I rounded it. Or about an hour. That's kind of scary. There's an asteroid. You have an hour. like, hopefully it'll never come that close. All right, let's try another one. Same kind of thing. Get more practice. So here we have a graph that shows the remaining balance on Y on a car loan after making X monthly payments. Write the equation of line and interpret the slope of the y-intercept. That's okay. Go ahead. Right? What is the remaining balance after 36 payments? So we need to interpret the slope. We need to interpret the y-intercept. And then we're going to write the equation of the line as well. And I forgot something about this part, but we'll find an answer too. Okay, so we're going to interpret the slope. First thing we need to do is find the slope. If you forget the formula, write it down every time. It's m equals y2 minus y1 over x2 minus x1. So we need two-order pairs. Do we have two-order pairs? Yes. When I find my slope, will it be negative or positive? Negative. How do you know? It's going down. So if you write a positive slope down, you've done something wrong. So let's see, y2, 15 minus 18 over 10 minus 0, negative 3 over 10, negative 3/10. But we're going to interpret that, so we need to use words like the balance and number of payments. The balance is the y, so the top at negative 3 has to do with the balance, and then the number of payments is the x, so that 10 has to do with the number of payments. But what I want you to do when you interpret the slope is write it so it is balance per payment. So not per 10 payments, but per payment. So we need to divide those. So I'm going to divide negative 3 divided by 10, and what do you get? Hopefully you don't need a calculator. 3/10. How do you write that? 3/10. How? 0.3. Just 0.3. Just 0.3. And it's going down. So what I'm going to say is I'm not going to say negative. I'm going to say balance decreases. I'm going to rewrite this. Balance decreases by 0.3. Does it go down by $0.3 every month? Does it go down by $0.3 every month? Why, Andrew?
It is because 0.3 is the portion of what you have to pay in total that goes down. It's not the amount, it's something like the quantity that you pay per payment.
Right, but my slope is just how much I pay per month. And it's 0.3. Am I paying 30 cents on this? Is it a car? You think I'm paying 30 cents on my car loan? What am I not noticing here? It's going to go down 0.3 every month, but that's not 30 cents. Yes, you see this right here? Thousands of dollars. We're going down $0.3 thousand each month. $0.3 thousand. 0.3 times 1,000. So we're going down $300 each month. Okay, 0.3 on the graph, but they made their scale different than like real life. $300 seems like more of a car payment than 30 cents. So we're going to go, balance decreases by $300 per payment or per month. I don't know if it's months. Is it months? Yeah, it's months. So that is interpret the slope. Interpret the y-intercept. So on this graph over here, the y-intercept is at 0, 18. What does that mean according to the situation? What does this point mean on the y-axis? The x is 0, the y is 18. What does that mean? These work like this. What is $18,000?
The balance.
The amount of the loan. That's how much you owe right away. It's $18,000 at the start before you paid anything. Okay, so that's the interpret the y-intercept would be car loan. Starts at $18,000. Then we have to write the equation of the line. So we're going to use point slope form. Y minus y1 equals m times x minus x1. We know our slope is -3/10. Do y minus, and you can use either ordered pair. Which ordered pair would you like to use? I prefer to use the one with 0 in it. But you can use whatever you want. I prefer the one with 0, so I'll go minus 18, 3/10 x minus 0. So we have y minus 18 equals -3/10 x. And then we're going to add 18 to both sides. And we'll have our equation. The same stuff we've been doing, you just kind of have to interpret the graph by using the words that are along the graph. When you're ready, you can go and turn your page so I can know that I'm ready to go on. If you're still copying it. We just have one more example. Okay. What happens if I do go too fast for you? Go on Canvas through OneLogin, and this video that I'm recording right now will be there. Also, I'll post the notes. So you can open up the notes as well. All right. Modeling with mathematics. 2 prom venues charge a rental fee plus a fee per student. Okay, a venue is just like where prom's going to take place. Like prom doesn't happen here. You guys know that? Prom's not here. It's usually at the Savannah Center, somewhere else. So we have to pay to use that. So here, when you're going to pick where you're going to have prom, you want to kind of see how much different places charge. So 2 prom venues charge a rental fee plus a fee per student. The table shows the total cost for different numbers of students at a place called Lakeside Inn. The total cost Y in dollars for X students at Sunview Resort, which is here, is represented by the equation Y equals 10X plus 600. Which venue charges less per student? How many students must attend for the total cost to be the same? So let's interpret Sunview Inn to start. Let's interpret this. 10 is being multiplied by X, and up here, X is the number of students. When we're done, Y is the, where's Y? Here. total cost. So the number 10 and the number 600, what are they representing? Two prom venues charge a rental fee plus a fee per student. X is the number of students. What's 10? That's the fee per student. That is money per student. So then what's 600? That's just the rental fee. If you have one student come, you're going to pay $600 plus $10. If nobody shows up to prom, you're still paying $600. Okay, that's happening. So that's the rental fee. Over here, could you look at this and immediately be able to tell me the cost money per student or the rental fee by looking at this? These are more like ordered pairs. This is for 100, it costs $1,500. For 125, it costs $1,800. For 150, it costs $2,100. We've got ordered pairs sitting here. Over here, the money per student, that 10 is like my slope. And the 600 was my y-intercept. Can I find the slope and y-intercept here so we can compare? How do we find the slope? How do we find the slope? Excellent. So you can use whatever two ordered pairs you want. I'm just going to use the first two. So 1,800 minus 1,500 over 125 minus 100, 300 over 25, so 12. Now what do we do after we have our slope? I want to compare them so they need to look the same. How do I find the equations? Point slope form. It's on the screen. Y minus y1 equals m times x minus x1. So we will do y minus 1,500 equals 12 times x minus 100. So I distribute and I get 12x minus 1,200. Now add 1,500. Cancel that out. Add 1,500. And I got y equals 12x plus 300. Which venue charges less per student? Sunview, because Sunview charges how much per student? $10. How much money does Lakeside Inn charge per student? 12. It's going to be the slope. Same thing. This is the money per student. So what do we say? Sunview, I'll just write it up here. I didn't organize it very well. Sunview charge is less per student. And then how many students must attend for the total cost to be the same? That is one way we can do it. Of course, I did not need a lot of space for that, but yeah, that's one way we can do it. How would you set them equal to each other? It's totally right. How would you do it? Mm-hmm. I really didn't organize my work well. I apologize if you're like, writing all over the place like I am. We would do 10x plus 600 is equal to 12x plus 300. So if we're trying to find where they're equal, we set them equal to each other. That's when the costs are equal. We've seen how many students that would be. So how would I solve an equation when I have x's on both sides? What do I do with the x's? Kind of, but they're on different sides of the equation. Move one of them. So which one should I move? Minus 10x. So now I have 600 equals 2x plus 300. So then when you subtract 300, right, we get 300 equals 2x. What's x equal? 150. So they are equal for how many students? So total cost is same for 150 students. Yeah, that looks like a mess. I'm sorry. I should have thought better about where I organized my work. Nobody's perfect. And then we have one more thing. They found one more venue. Maple Ridge venue charges a rental fee plus $10 fee per student. If the total cost is $1,900 for 140 students, describe the number of students that must attend for the total cost at Maple Ridge to be less than the total cost of the other two venues. And we're going to use a graph to justify our answer. So for Maple Ridge, they charge $10 per student. What information is that giving me for my equation? That's the slope. That's right. So I know my equation is going to be something like y equals 10x. But this is the slope, which is m. We also know the total cost is $1,900 for 140 students. That is telling me for 140x, we get $1,900 out. If I input 140 students, I get $1,900 out. So that's an ordered pair. So if I know the slope and I know a point, how do I find the equation? Point slope form. Y minus y1 equals m times x minus x1, because I have a point and the slope. Y minus 1,900 equals 10 times x minus 140. And we'll distribute. And then I'll add 1,900. Now we're going to graph describe the number of students must attend for the total cost of Maple Ridge to be less than the total cost of the other two venues. Let's graph and look at the graph first. I can show you algebraically as well. Well, let's look visually. So we're going to graph all three of them. If you want to like dot one and dash another, or do different colors so you can tell which is, excuse me, which is which. Sketch all three options. Do you know why I gave you only the first quadrant and not the whole thing? Because what's the x value represent? What's our x? Number of students? Can't have negative. And what's my y value represent? Total cost, right? Let's look at our our y-intercepts for each of these. The y-intercept interpreted, what does the y-intercept mean for 500 here? We talked about it up here. What is the 600? What is that y-intercept? That's a rental fee for just having the room. So we've got a 600, we've got a 500, and we have a 300. So what do you think I should count by on my y-axis? Hundreds? Okay. So if you change the scale, if you're counting by something other than 1, please label a couple of them on that axis so I know what you're counting by. Not a mind reader. So that's going to be hundreds. And then what should we count by for number of students? Let's see. Up here in this table, we've got 100 through 200. Maple Ridge gives us an example of 140. How many students was it when the two were equal in that previous one? 150. So what do you think? 20? Let me see. 20, 40. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 20 could work. Okay. 20. Sure. I labeled a few of those points, just so we can tell we're playing with them. And we'll graph each of these. So let's graph 10x plus 500. This is just a tiny bit challenging because our slope is not, let me rephrase that. It's our scale is not the same on this axis as it is on this axis. So you're going to just be careful and use your slope. So our slope is 10x, our y-intercept is 500, so we're going to go to 500. 1, 2, 3, 500. We're going to start there, and then you have to go up 10 over 1. That's going to be hard. Let's go up 100. Let's go up 100 over what number gives us 10? How this slope reduces to 10. 100 over what gives us 10 over 1? Okay, so let's go for our slope. Let's go up 100 over 10. Up 100 over 10. Up 100 over 10. Up 100 over 10. 100, 100. So that's Maple. I dotted mine. I can tell the difference. All right, what's another one? We've got Sunview is y equals 10x plus 600. So we could do that the same way we did Maple. Start at 600. Here's 600. Go up 100 over 10. Up 100 over 10. Up 100 over 10. Up 100 over 10. 100 over 10. What do you know about Sunview and Maple? Maple and Sunview, these two that we've graphed so far. What do you know about that? If you're deciding where prom's going to be held, tell me something about the total cost between these two. Sunview started at 600. Oh, my M is in a bad spot now. Sunview's my top one. M is my bottom one. So total cost-wise, which one's on the bottom? Maple. So the slopes are exactly the same. It's just Sunview has more for the room. So I wouldn't even go with Sunview because I know Maple's cheaper. And then what is the last one? The last one we had our equation was Lakeside. And the equation is 12x plus 300. That one's going to be a little bit harder to graph, but let's make 12 into something that we could go up and over easier on 12. What does 12 go into? What? What doesn't matter for you? 12 over 1. I was trying to think like hundreds. 12 goes into 60. So it goes by 600 over what number? I'm going to have to multiply that by 50. Okay, I could do that one. So I'm just making an equivalent fraction so I don't have to try to count 12 at a time. So I'm going to go up 600 over 50, and I'm starting at 300. Starting at 300, I'm going to go up, what did I say? Up 600. Okay. 1, 2, 3, 4, 5, 600 over 50. So here's 40, here's 50. Straight edge. Yeah, they're not going to cross on the graph. We're going to get too, we didn't zoom in enough. But if I did go out, they'd eventually cross. What was the question? For how many students is Maple Ridge less than? So Maple Ridge, the M, is less than the other two venues. Okay, so this dotted line is eventually going to be the lowest one. If I just kept going out on my graph, it's eventually going to be the lowest one. If I can find where my dotted one and this solid line cross, then I will know where it's bigger. So to find where two of them cross, we set them equal to each other, just like you did earlier. So I'm going to set equal Maple Ridge, and what is this line? Lakeside. So I'm going to set those equal to each other. I'll just put it in a different color so you can tell I'm doing it right here. So Maple Ridge was 10x plus 500. Lakeside is 12x plus 300. And let's see where those are equal. So subtract 10x. And then subtract 300, and we get 100 students. So out here at 100 students, if my graph is big enough, out there at 100 students is where they cross. So Maple Ridge is the lowest line after how many students? 100. So that would be our answer. Maple Ridge has least total cost after 100 students. Now, your assignment won't even be as hard as ours today. This is good, like, seeing what's to come, because what we're going to be doing next is solving systems and equations, so it's good to see that. But your homework's pretty easy. So the rest of the class, you have a short assignment that's in the book. So you're going to want to borrow one of my books today, and I moved them all over there, but we can pass them out. We'll just like, if you guys want to grab a couple, pass them this way, and then they're all the way in the back. I'll put up the assignment. And then it's really short. Once you get that done, I have a review. We're going to have a short quiz on Friday. It's not on this stuff. It's on transformations. So your review is on transformations. So if you think this stuff's pretty easy, I'm going to work on my transformations review first. Go for it. So I'm here to ask questions and help you. If you know your transformation stuff and you're like, I'll do that second, you want to work on the book word first, either. But I should not see Snapchatting or phones out for any other purpose that you have music in your ear, and that's fine. Just one ear, just in case I talk to you. And then please ask questions while you're working. All right? Okay.